We've been talking about multiplicity a little bit, and for this question, question number 10, it's almost imperative that you know about multiplicity. You almost can't do this question if you don't, especially without a calculator. It would be very difficult to do it, just because the numbers are so small that it would be difficult in my opinion. So here's how I would do this. It says, if f prime of x equals this equation here, then f has which of the following relative extrema? So remember that relative extrema, like maximums and minimums, come from the zeros of the first derivative. And since this is the first derivative, I'm looking for the zeros of this function. Well, they already did the hard work for us, because our job would be essentially to find the zeros, would be to factor it out. Well, it's already factored out. So essentially, we just need to set all of these factors equal to 0. So if I set x plus 1 equal to 0, I get negative 1. If I set x plus 2 squared equal to 0, I still get negative 2. And if I set x plus 3 cubed equal to 0, I still get negative 3. So my three zeros are at negative 3, negative 2, and negative 1. Now, I've actually talked about multiplicity before in class, and I'm not sure how many of you guys are familiar with it from your honors pre-calculus or regular pre-calculus classes. But multiplicity is essentially looking at the power of the factor. So for negative 3, I'm looking at this one. The exponent on the x plus 3 factor is 3, so it has an odd multiplicity. Okay, so a multiplicity of 3 is odd. An odd multiplicity means that the graph crosses through the x-axis at that point. Negative 2, the factor is here, so x plus 2 has an even multiplicity because it has a multiplicity of 2. So that means it actually is going to bounce at that point. It's not going to cross through at negative 2. At that 0, it will just bounce and come off. And then at negative 1, it has a multiplicity of 1, since there's a little invisible 1 up here, which means that at this multiplicity, it's actually going to cross through again because it's an odd multiplicity. Now, the only thing we have left to do now that we know that it crosses here, bounces here, crosses here, is we need to figure out what the end behavior of this graph looks like so I know where it's going up or down and all that good stuff. So, in order to know the end behavior, you need to know the leading coefficient, if it's positive or negative, and you need to know the degree of the polynomial. So if I look at here, I see negative, so that tells me it's going to be a negative leading coefficient because none of the other ones are negative, so that won't mess with anything. So a negative leading coefficient, and as far as the degree is concerned, I have 1 power of x here. I have x being squared in this middle one, so I know that I'm going to have 2 powers of x there. And I have x being cubed in this last one, so I know I'm going to have 3 powers of x there. So x cubed, x squared, and x, if you multiply those together, you're going to get x to the 6th. So I know that my negative x to the 6th, is going to be my leading term. So the degree is 6 and it's negative. So since the degree of this polynomial is positive, it's going to look like a parabola. But it's going to be negative, which means it's going to look like a parabola facing down. So when I start drawing my graph, I know that my end behavior goes down this way and down this way, because it's a parabola facing down. And I just kind of complete the dots by connecting through the zeros. So I know it crosses through at negative 3, I know that it bounces at 2, and I know it crosses through at 1. So it should look something like that. My graph should look something like that. Which tells me that these values are negative here, positive here, positive here, and negative over here. So it says f has which of the following relative extrema? So at negative 3, all right, negative 3 goes from negative to positive. That means this is a minimum. Okay, from negative to positive is from decreasing to increasing. So obviously a relative maxima at x equals negative 3 is not going to happen. So I know for sure that this is not an answer. The next one, a relative minimum at x equals negative 2. Well, negative 2 is not a minimum or a maximum, and again, that's because it goes from positive to positive, so the original function is going from increasing to increasing, which means that this is neither a maximum nor a minimum. And the last one, a relative maximum at x equals negative 1. Well, this one's going from positive to negative, so yes, that is in fact a maximum. From positive to negative would be a maximum, so the third one is true. So the answer choice is 3 only, which is B.